Hello folks, welcome. Today we're going to have an experiment showing what we can do with voltage versus amps. The reason we want to use voltage is because the less amps we use, the less power consumption, the less watts. See, voltage times amps equals power usage equals watts. So what I'm going to show, I'm about to show you how you can run a motor, a generator, another motor, and an LED on 5 watts. 5 watts. That's
Our input source is 19 volts and it's capable of providing 2 amps. But as you can see, we're only using 0.78, 0.77 amps. So we're not using the full 2 amps, we're using less than 1 amp. Okay, here we have the motor that is now connected. Green is negative, red is positive, connected to the motor. And the motor spins a generator. From the generator, we got it hooked up to our meter. 4.6 volts, not very impressive. 4.6 volts from our generator. There's no power going to the generator except for the shaft being connected to the motor. Okay, but so it's not very impressive, but watch what happens when we hook up the capacitor parallel, like a short circuit, to our output. And that's what we're going to do right now. You'll hear the noise as soon as I hook it up to the capacitor. Okay, we hooked up the capacitor to like making a short. You can hear the difference in the sound. And since it's spinning a lot faster, we're going to go to our voltage now. 31 volts. Keep in mind that we're producing the 31 volts from our source. Our source, we go back. You can see it's 19 volt source. And we're not using the full 2 amps. We're only using, again, still pretty much the same, 0.77. That's with the load. It hasn't changed since we connected and disconnected our motors. Okay, let's disconnect them. Motor's disconnected. Motor's not running. And our amperage draw is pretty much the same. Nothing's changed. See, high voltage is what's doing all the work. We're going to connect it again. Sorry, it's hard to see the camera and do the other thing at the same time. Okay, once we connect the motor again, motor spinning and generating electricity, our amperage draw from the source hasn't changed, 0.77, 0.78. So although we're running a motor plus another load, the generator, we're creating 31 volts. Okay, next we're gonna use those 31 volts to run another motor and see what happens.
Incidentally, I wanted to add a little comment to this area here on the video that we're producing 30-some volts with normal current coming out of that generator. And remember, we're only using 19 volts as a source. So I know it's not the same, but our output is in voltage is more than our input, which is 19. So I just wanted to put that in, make sure that everybody is aware of that.
Okay, this is still with the motor generator combo still running. Okay, and still we're getting 32 volts. Now we're going to disconnect our meter and hook it up to our other motor. So now we're going to have two motors and a generator running all at once, and we'll see what it does to the amp draw. Okay, so we're going to disconnect our meter. Okay, we're hooking it up to the extra motor. Okay, as you can see, the motor is now turning. 24 volt motor. We have the generator that's providing the electricity to the motor, and we have the drive motor, and then we're going to follow it all the way to our source. Okay, now what does our source tell us? Hey, you see that? The amperage is still the same. Okay, so we're not using a lot of amps, even though we've loaded it once, twice, 3 times, and no change on the amps. Still 19 volts, 0.77 amps. Okay, following up, this is called a chip LED. On its own, it's 10 watts. Just by itself, 10 watts. It needs to light up 10 watts. Okay, and we're gonna hook it up in line with our motor that's driving the generator, that's driving another motor, and we're gonna use 10 watts along with that. So we're gonna hook up this LED in series with the last motor that we hooked up. Okay, so let's see what happens. Okay, we're about to connect the LED in series with the motor, and it's going to be a little bright. A lot bright. Okay, let's see what happens to our amp draw. 0.77. So you tell me what's going on. We got one motor being fed 200 volts, driving a generator, driving a 10 watt LED, driving another motor, and if you make the calculations, you need to multiply 19 volts times 0.75. So let me do that for you. Okay, we said 19 volts and it's drawing 0.75 regardless of we're running two motors, a generator, and a 10 watt LED. So let's figure this out. 19 times 0.77, let's be generous, 14.63 watts. So let's write this down. So remember, we have a 10 watt LED. Running on that. So that leaves us 4.63 watts left over to run two motors and a generator. So I'm not going to say it's over Unity, but I'm going to say it's pretty close. So that's the total input into our system, 14.63 from our 19 volt battery source minus 10 watts for the LED leaves us only a balance of 4.63 watts. With that we're running, I'll show you again, we're running a motor at pretty high speed. We're running a generator. The generator is running the 10 watt LED, and it's running another motor. By the way, these are 24 volt motors. Okay, and curiously, remember we're not using a lot of amps, so the LED does not get hot like normal. It gets pretty warm, you know. But if I were to connect it to a regular 12 volt source, it would heat up in about 5 seconds, where you wouldn't be able to touch it like I'm doing right now. It would burn your finger. I got my finger behind it. It's not burning my finger. It is pretty warm, but it's not enough to burn me. Whereas if I hook it up to a normal 12 volt battery, it would cause me it to burn my finger. So anyway, it's not Overunity, I don't think, but let's say it's very, very close. We have a little secret here. Part of that, remember, is the secret using the capacitor. Now let me show you what happens without the capacitor. All of a sudden things go like normal. The generator will slow down. Okay, so we're going to unhook. So you see it's almost to a standstill, and the output on the light is real low. See? But when we hook up the capacitor to it, it's like steroids. Watch this. See the revolutions? Real slow. Okay, we hooked it back up, and look at the LED light. Back to normal. Everything's turning. Now that's with all this load. Now we take everything off, and that's how it runs now without the loads. And remember, we're still same amperage, 0.77 amps. We're on the 40 amp scale, only providing 0.77 amps at 19 volts. So no wonder nothing gets hot. Okay, there's a little transistor in here that I'm going to show you. I can hold this steady in it. It's a MOSFET transistor. It's doing all the work. It's right here. It's warm, but it's not hot. That's because it's not working. We're not driving all those amps through it. We're not driving amps, we're driving high voltage. So that's the secret, guys. Don't use amps. Amps destroys the battery. Amps destroy your source.
Hey guys, I want to thank you all for watching this video. And remember, this could be upscaled. I mean, think about hybrid cars. They're running on DC voltage. And think what we could do with the capacitor and DC voltage. Make it run faster and use little of that lithium battery. So what would that mean? Extended range. That's what it would mean. The car manufacturers are missing the 8 ball on this. I mean, we could make really good improvements, but we're not. This technology is new. So anyway, thank you for watching, and subscribe. Thank you.